So Karima, you need to sign up for this Snowflake. You don't need any credit card and all. You just need to sign up. Like you need to fill this form. Your first name, last name, email, your personal email, company name. This is optional. You can give any of the company name. Just I will quickly write it out. Uh, so company name, anything. Just click on no and next. Select the. So if on the second screen, you need to select the business critical edition. Okay. Just see my screen. Business critical and AWS. And in the region, as we select the Asia Pacific Mumbai.
Okay.
And just click on get started. You will get one email on your Gmail. Whatever the email you provided, you will get like one email.
Okay.
Okay, I got the link. So this is in the update section. See, this is what you will get. Just click on activate. Click on get started. Okay, so once you sign up, once you change your password, this is the screen you will see. So this is like a Snowflake. So we don't have any offline tools. So the only place where we'll write queries in the browser. So this is the only place in Oracle. Like Oracle have SQL Developer and Microsoft Management Studio. Same like this is the tool. Okay, which runs in the browser.
Okay.
So today's class, this will be the first class coming to the data loading session. Today will be the first class. So in this class, what I'll show you is, what I'll demonstrate is we'll create one database, and again we'll create one table, and we will load the data into the web UI using the web UI. So let's coming to the Snowflake, right? Every database, they have their own data types and all. Like let's say in Oracle, we have a cloud, which you don't see in Microsoft SQL Server or any other. So there are like few specific data types for each and every DB, right? So coming to the Snowflake, these are the available data types for us. So numeric, these are the data types: string, date, semi-structure, which you don't see in other databases. Here you will see, and Boolean. Okay, these are the available data types in Snowflake. So for semi-structured data, so as this database is compatible with handling both structured and semi-structured data. So for semi-structured data, when I say semi-structured, JSON, Avro, Parquet, XML, all this like semi-structured data, these data types will handle this particular format. Okay, again for geographical data, latitude and longitude, we have this special data types pattern. Okay. Coming to the constraints in Snowflake, we can specify the primary key constraint, unique key constraint, foreign key, and not null. Okay, so these are the constraints. But coming to the enforcement, Snowflake will only enforce not null constraint. So what does it mean? So what is primary key? Primary key means like when you specify a primary key on any column, what is our expectations? It should not allow duplicates, right? In Snowflake, while creating a table, you can specify the primary key, but once you load the duplicate data, it will take. Means the primary key, unique key, as a metadata wise, you can give the syntax, but Snowflake is not enforcing. Due to some reasons, they are not enforcing anything. The only constraints they are enforcing is not null constraint. Okay, so what is not null constraint is, let's say you are inserting like 10 rows, 9th row is blank, then it won't allow you to insert in that particular column, it won't allow you to insert any data which is blank and all. Okay, so this is like a limitation, nothing we can do. So how you will enforce primary key? Again, it is developer responsibility to make sure you are not loading any nulls or any duplicates and all. Okay, so this is coming to the constraints and all. So in Snowflake, all right. So in Snowflake, we have a concept of staging areas. Staging. The staging is of external staging and internal staging. Okay. So what is external staging area? So this Snowflake has a capability to connect to one of the cloud. So either that could be AWS or Azure or GCP. So like let's say your company is using some cloud to store their data. So in AWS we have S3, Azure we have a blob storage, Google Cloud Storage. Okay, let's say you have the data in one of this cloud storage. What you can do is you can connect your Snowflake to one of this cloud and you can load data from one of this cloud to Snowflake. Okay, so we have the concept of external staging area. So what is stage? A data stage is used for loading the data from files into Snowflake tables and unloading data into files. Okay, so let's say this is our AWS S3. Okay, this is our Snowflake account. Okay, then what I'm saying here is this is like inside we have a we'll be having databases and tables. Let's take this as a Snowflake table, and you have the data in Amazon S3. Okay, so you cannot directly load data into Snowflake table. You cannot like anytime you cannot load data directly into Snowflake table. So what you have to do, so you have we have two concepts here, internal stage and external stage. So first of all, what is staging area is? Staging area is a place where we temporarily store data before moving them into permanent locations. Okay. So like let's say you went to supermarket, you purchased a few of the items, like groceries and maybe clothes or something. After coming home, what you will do, you'll unpack all the bags, like you'll move the particular groceries to kitchen again. Any clothes will move to the wardrobe, right? You will like. So staging area, what is that? The place where we temporarily store the data before moving them into tables. That is called staging area. So in ETL world, you will see like staging tables, staging folders, right? Same way, this external stage and internal stage. So let's take this as an external stage, internal stage. So before moving this file, so I have a file called maybe sales.csv. I have this file. Now I want to load the data from this file into my table. So the table name is sales. Okay. I cannot directly load into table. So first of all, I need to go to external stage. So I have to go to the external stage. I need to load this. So what is external stage? So AWS S3, Azure Blob, Google Cloud Storage, GCP. These three clouds will act as a external staging area to Snowflake. Okay, when I say external stage, it is nothing but we are referring to one of this cloud. Okay, so then what I will do? So this will become my AWS account now. So I will take this file, I will load the data into AWS S3, then I'll connect my Snowflake account to to this cloud, AWS. With login credentials, I'll connect my Snowflake to AWS account, then I'll transfer this file which is sitting here to my Snowflake table. Okay. So now you might get question like let's say your company is not using any cloud. They're like running it on-prem. Then how we can load the data into Snowflake? So the second way is if your company is not using any of the clouds, then the second option available for is we need to load the data into internal staging area. Okay, what is internal staging area? So this is a space provided by Snowflake. Snowflake will provide some space. You can load as much of data you want. And again, after loading into internal stage, you have to move that data permanently into tables. So yeah, this is a different company. AWS is a different company. Snowflake is a different company. So if your company is using one of this cloud, they will provide you the login credentials. Coming to as per our training is concerned, you need to sign up for Snowflake and also for AWS cloud account.
Okay.
So this is about external stage and internal stage. Just keep this on mind. So now we'll jump to a different topic. Okay. So in Snowflake, we have, remember like in the demo and maybe in other, I was referring to virtual warehouses. So yeah, let's talk about the Snowflake virtual warehouses. Okay. So in this topic, we'll see what is Snowflake virtual warehouse, what is its purpose, and what is the use case, and in real time, how to select the right warehouse sizes and all. Warehouse is nothing to do with data. They just named it as a virtual warehouse. So in the back end, it is simple hardware. It's just like a CPU, RAM, and SSD. So here, if you click on the screen, when you click on the create, it will show you the list of the warehouses: extra small, small, medium, large, extra large. Okay, we'll see the warehouses of different sizes, which starts with extra small and it will go on till 6x large. Okay, so let's understand what is this virtual warehouse. So a virtual warehouse, often referred to as simply as a warehouse, is a cluster of computing resource in Snowflake. Okay, a warehouse provides the required resources such as CPU, memory, and temporary storage. Warehouses are required for queries as well as DML operations, including loading data into tables. Okay, so let me simplify it. I don't read the PPT, don't worry. So what is virtual warehouse? So if you are querying any table, right, it needs some computing power, right? Because when you are creating when you are modifying any data, when you're deleting any data, you need some computing power, right? You need one server. Basically, a virtual warehouse, the term is a little misleading. Don't confuse with data. It has nothing to do with data. They named it as a warehouse, but it has nothing to do with data. So virtual machine consists of a CPU, RAM, SSD. It doesn't contain any data, zero data. You can consider it like a brand new laptop without any data, without like anything. It is just like an empty system. Okay. So why we need virtual warehouses? If you are loading the data into Snowflake, then we need a virtual warehouse, because loading, in order to process that load, we need some computer behind in the backend. That computing is nothing but virtual warehouse. They're calling it as a virtual warehouse. For loading the data, we need virtual warehouse. For downloading the data, we need virtual warehouse. So in Snowflake, we don't say downloading, we'll say unloading the data. For loading the data, unloading the data, and also if you are like deleting or like any DML operations, basically like for the loading and also for querying the data, loading the data, unloading the data, querying the data, we need Snowflake virtual warehouses. So it provides the required computing power to process these operations. So warehouses can be started and stopped at any time. That means, so in traditional RDMS, if you are running the Oracle on-prem and all, even though you use Oracle or not, the servers will run 24/7, right? Anytime you log into Office, if you write a query, you will get the results, right? It's not like once your office hours is done, they don't simply switch off the server. They will run 24/7. As this is a cloud-based data warehouse, we can start and stop our virtual warehouses anytime. So you can see this is a warehouse, default warehouse. This is in currently in suspended state. Okay. So this is in suspended state. I can resume. So you can see the status is started. Okay. I can simply suspend also. Okay. I can simply suspend also. It got suspended. That means we can start and stop warehouses at any time. Start, stop at any time as you require. They can be resized at any time, even while running, to accommodate the need for more or less computing resource based upon the type of operations being performed by the warehouse. That means, see, we have options for resizing also. So let's say my query, let's write some query. So let's take this here. You can see 103 MB. Just click on this. If you signed up, right, make sure you are clicking, click on this. This is really annoying. Every time you run, this will waste like 1 second of time. So anyway, you can see the query is running, right? The query like is running, and you can see I got results in 4.24 seconds, in around like approximately like 5 seconds, right? I got results. Okay, this is like a small table. So 103 MB, I got the data very quickly. So what I'll do, let's pick the big table. See, 10 GB, it's not like a small table. Let's write a query on this 10 GB of table. So now you won't get results in 4 seconds. 10 GB means it's like a huge data, right? It has to scan 10 GB of data. While this is running, I have an option to resize from extra small to medium. We can resize. So based upon use case and all, we can resize the servers. Anyway, let it run. While it is running, we can start and stop anytime. We can resize it. Resize it even while your query is running, you can resize it. Okay, now coming back to the sizes, you will get a question like, what are the sizes? What is the difference between them, right? You will get a question like, what is the difference between extra and small? So you can see it is starting with extra small, small, medium, large, extra large. It will go on. June or July. I think it's like 2 months. They released two more new clusters. So yeah, 2x large, 4x. So here we can see. So 4x and 5x and 6x clusters. These two are newly introduced last month. Okay, last month they added two more clusters. So now what is the difference? Let's come back to the sizes and the differences. Extra small, small, medium, large. But extra small, you can see it comes with one server. Okay, in the back end, they only have one server. Again, what is the configuration of server? I don't know. So Snowflake, that's a Snowflake proprietary info. They are not sharing. Only thing what we know is the difference in sizes. We'll know like number of nodes or servers in the backend. For extra small, you can see we have one server, whereas for small, we have two servers. Medium, we have four servers. Large, eight. Each size it comes like it will double. So 1 into 2, 2 plus 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32. That means the size is getting double. So small comes with two servers. Medium, it is like double to that. Large, double to medium. Extra large, double to that. So that is the difference between size. So again, one question will come to you. So you want to load 10 GB of data, then what is the correct size, you will ask. So for data loading, how you'll determine the size? There is a no straightforward answer for that. So once like this class is finished, we'll load the data. In the next class, we'll load the data. Once the data loading classes are finished, right? In that case, after that, I'll explain you how to do the load testing and how to select the right warehouse size. I'll explain. Okay. Again, if you have those questions, just park it, keep it in the parking, write down the questions and keep it aside. I will answer at the right time. Okay. So yeah, this is the difference. Coming to the warehouse size, the difference between sizes is nothing but it comes like the server size is different for each and every warehouse size. Okay. So one certification question which comes for here is, what is the default warehouse size if you are creating the warehouse from the UI? The answer is extra large. You can see default warehouse created in the web interface. That means when I'm creating a new virtual warehouse, okay, let's say I want to load data from Salesforce. For this, I want to use this warehouse. So what is the default size, guys? Did I selected anything? By default, it's selected extra large. Then as this is a cloud based, the billing will be per second, right? Per second billing will apply. So if you are using the extra small for 1 hour, you will be charged with one Snowflake credit. So what is Snowflake credit? I explained, right? Snowflake editions, if you remember, like. So if you are using the business critical, then they are charging you $4 per one credit. That means if you are running this virtual warehouse for one hour, it is saying like one credit you will be consumed. So here also it will be mentioned. So you no need to worry to remember all these things. Here you can see extra small one credit. That means if you are using the extra small for 1 hour, you will be charged with one credit. Then one credit will cost you $4. Then again you need to break that dollar into per second info per second, and this is the rate cents 0.0003 cents. If you are using a small for 1 second, then this is the charge. Okay, same way till 4x large. So everyone understand, right? What is the difference between the sizes and all? Are we good
Yes.
here? Yeah.
Yes.
So yeah, one more certification question. So when you started a warehouse, okay, that means let me go back to my query. I got the results. Let me suspend this warehouse. So where is my query? I deleted the query. So in 2 minutes 40 seconds, it scanned 40 GB of no 10 GB of the data using that two extra small. So what is the state of the warehouse, guys? Currently, you can see it is in the suspended state. Means the computer in the backend is switched off. But when we run the query, what will happen? The system will be switched on and it will process this query, right? So when I run this, so you can see now it is it changed the status from suspended to switched on state, right? So whenever this has happened, I mean, whenever you are starting the warehouse, here I'm saying like it's a per second billing. For first 1 minute, like let's say for 1 second, let's say they are charging one paise, just for our understanding. They are charging one paise. So if you used how many, so see, I got my results in 3 seconds. Let's say after 3 seconds, I'm suspending this warehouse. Let's say after 3 seconds, I suspended this warehouse. Then how much they should charge us for 3 seconds, right?
Yeah. 3 paisa.
3 paise. But they will charge you 60 paise in this because first 1 minute, in first 1 minute, even if you use 20 seconds, 30 seconds, or maybe like 40 seconds, you will be charged first 1 minute fully. That means they'll charge you 60 paise. Okay. Same like our mobile, like few years back, like remember, like first 1 minute it is like full charge. After 1 minute, the per second will apply. Same concept here also. First 1 minute they will charge you, even if you use like 10 seconds, they'll charge you for 60 seconds. After 60 seconds, if you used for 5 seconds, so how much you should, they'll charge you 65, right? You will be charged with 65 paise. Understand? And that is a certification question. First 1 minute is full charge. After 1 minute, the per second billing will apply. Okay. Now in the cloud world, you must have heard this term auto scaling, right? Auto scaling. So Snowflake, this DB is also capable of automatically scaling its warehouse size. I mean the server size. So when during the peak workload times, what it will do is the database will scale up. I mean the warehouse, the computing resources will scale up. When there is like lesser requirement, it will scale down. Okay. So let's see the auto scaling in Snowflake. After that, we'll see this maximized mode and its use case. So what is auto scaling in Snowflake? The mode is enabled by specifying different value for maximum and minimum clusters. So this part is why. Let me close this. Okay. So now we are talking about auto scaling. So let's see how to enable auto scaling in Snowflake. So after going back to warehouses, so let's say I want to create a new warehouse. So click on create a new warehouse, and let's name this warehouse. I want to load the data from Hadoop. Okay, the data whatever I'm extracting from Hadoop, I want to use this warehouse size. How to determine the correct size, I'll come to that, but for now I'm selecting the extra small. Then you can see the minimum clusters and maximum clusters. I'll come to that. What is clusters? I'll come to this. But how we can enable auto scaling is you need to give the different number in minimum and maximum. Okay. So the mode is enabled by specifying different values for the maximum and minimum clusters. So let's say maximum up to I can go till 10 clusters, not more than that. Up to 10 clusters I can go. Now let's see what is the cluster. Let's understand what is cluster. So in the extra small, how many servers I have, guys? How many servers I have in extra small? Can anyone say how many servers we have in extra small?
One.
Sorry.
One. One server.
So that means if I create one cluster for extra small, how many servers will be there? So the outer box is cluster, and inside that cluster, I have only one server. So this is like a first cluster, or like I'll say like cluster one. So in cluster one, this will become my server one. Okay. Now, if I create the second cluster, how many servers? Again, it will have only one server. And again, this will become my cluster two. So inside this cluster two, this will be my server one, right? So like this, I can multiply up to 10. Okay. Sorry, multiply in the sense, don't get confused. Like that, I can create up to 10 clusters. So two clusters are there. This will be third cluster, fourth cluster, fifth, sixth, seventh, eighth, ninth, 10th. Okay. Inside that, we have like again servers. Like that, I can go till maximum of 10 clusters in Snowflake. That means if I create 10 clusters, so what is there in the backend? 10 systems, right? Everyone agree? I'll have 10 servers because in the
Yes.
cluster one, server two, like the 10 clusters. So so for extras for small, so let's say this is a small cluster one. Inside cluster for server for small size, how many servers are there? Two, right? That means for each cluster we have two servers for extra for small. So what is the size of this one which I draw here? This is the size is extra small here. Extra small, we have only one cluster. So one server per cluster. Whereas for small, and the size of this is small. So for small, each cluster, this will be my cluster one. How many servers are there? This is my server one. This will become my server two. That means if I created two clusters, how many systems are there in the backend? Two systems, right? Total how many? If I combine these two clusters, four servers, right? Now you understand the difference. Snowflake is very powerful. You compare with any Redshift and Google BigQuery. This is very powerful because let me come here and show you. So how many systems are there, guys? 512 systems for one cluster. So if I create 10 clusters, 512 into 10, that means 5120 computers in the back end running and processing your data parallelly. You will get a results like you can scan petabytes of data in seconds. Are we good with clusters? Everyone understand what is cluster?
Yeah. Cluster is something like a group of systems, right?
Yeah. Vansh.
Okay.
Okay. Cluster, this is about cluster. Cluster contains like a group of computers. Yes, you can say that. Now, what is this auto scaling? Now I'm jumping back to this auto scaling. So this mode is enabled by specifying different values for maximum and minimum clusters. So now if I want to enable the clustering, I need to specify the the different number. So here I'm saying minimum, the minimum cluster should be 1, and the maximum cluster I'm saying like 5 clusters. Okay. So what will happen when we define a clustering? So what is the use case of it? So usually, let's say coming to this on-prem databases and all, let's say you are using Oracle. Okay, you are using Oracle. Your query is running very slow, and the other teams are also using same servers. So till what extent okay? So what is the usage of my CPU? 24%. Okay, you can connect to my system using remote desktop or whatever. Like how many PPTs I can open? Maybe like if I open 100 PPTs, the CPU utilization will spike up to 80%. Same like if you are writing more and more queries on Oracle or anything, in the back end, it will put a load on the CPUs, servers, right? So till what extent the server can take the load? 100%. So what will happen if my usage spike to 100? Then what will happen? Is this paint will stay? Everything will crash, right? All the softwares, whatever I open, it will all crash. Oracle database is nothing but one software, right? Once you install Oracle and all, database is nothing but it's a kind of software, right? You can create your own databases if you want. Yeah, cluster one and cluster two. Yeah, let's talk about auto scaling. Sorry, I'm deviating. So auto scaling, what is the use case of the auto scaling is I was saying, uh, let's say Vamshi submitted his query. So Vamshi wants to scan, maybe like he ran the query on 5 GB of data. Okay, so before moving on that, whenever we submitted a query, I already explained, but whenever we submit a query, so what will happen? The query will come to this service layer. Okay, cloud service layer it will come. So this optimizer, what it will do, it will take the query, it will try to optimize that query. If you wrote any long length bad query, it will try to optimize, it will create a query plan. The query plan will be submitted to virtual warehouse layer. This is the layer we are talking about, virtual warehouse. Okay. So what will virtual warehouse initially it is switched off state. As soon as it receives the query plan, it will get active. Then it will come to data storage. It will extract the required data of that particular table to the virtual warehouse. Then the data processing will happen over here. Okay. So whenever it receives the query plan, this virtual warehouse is capable of determining two things. Okay. So what it will determine? It will try to determine, let's say, based upon that query, average time. What is the average time the query will run? Okay. So then it will say like maybe like it will determine like 5 minutes based upon the few parameters, and also it will also determine what is the required CPU to process this query. Maybe like 20% CPU is required to process this query. It is capable of determining these two things instantly as soon as it receives the query plan. Okay. Now let's say Vamshi submitted his query. So yeah, so he is scanning 5 GB of data. He wrote his query. Maybe the query is like select star from sales and group by some conditions. He submitted his query. Let's say Vamshi query will run for next 10 minutes. Okay. And let's say, hypothetically, let's assume that it requires 90% of CPU to process this query. So then what will happen? He submitted his query. The query is currently is in process. In this meantime, I want to write I submitted my query. My query needs like at least 20% of the CPU. Or like let's say my query, I submitted my query on 1 GB of data, and my query needs like 10% of CPU. Okay. In that case, what will happen? My query will be submitted to the same server. My query is currently in process. In this meantime, like let's say Arun submitted one more query. Okay. Now Arun wants to, we all working for the same team. Then Arun submitted his query. This time maybe Arun wants to scan the table size of another 10 GB. and this definitely needs 10 minutes at least to process this query. Then what will happen? Do we have any free space in the server? Because 90% of the CPU Vamshi query is consuming. Again, don't go logically, guys. So here, like 5 GB, I kept like 90, and don't go with the numbers and all. Just high level, just get the idea. So Vamshi submitted his query, and is like his query blocked around 90% of CPU. I submitted my query 10%. So total 100% of the CPU play, CPU 100% of CPU is in currently in utilization. Now Arun will submit the same query. The query will come and Snowflake will detect this scenario that it don't have any available free space or free resource to process to handle Arun query. Then what will happen? Arun query will be in queue. That means it will rotate. He will never get results. So Arun query will queue. How long he needs to wait? Let's say Arun query needs uh, maybe like 30% of space, or like let's say 10%. Let's assume with this query needs 10% of CPU. Then what will happen? Either Vamshi should get results or I should get results. So let's say as I'm running on the small amount of data, I got my results quickly. So Mahesh got his results. Then what will happen? So 10% of the CPU. Okay, let's not go with this example. Let's say Vamshi got his results. Then 90% of CPU utilization will be available, right? Then what will happen? Snowflake will accept Arun query because Vamshi got his result. Then Arun query will be handled by Snowflake. So, but here in a nutshell, Arun has to wait till these two people got a results. He needs to wait because my server is busy. In Oracle and all, same thing. In on-prem, you'll have a fixed number of servers. So the other person, if the query is running, no, he needs to wait. He needs to wait because till the CPU is available, the other person needs to wait. You might not see you are like waiting and all, but again, you will experience like your query will run for very long time. Okay, I hope you got. So what is the use of auto scaling now? Okay, the story is good, like three people. Whenever it doesn't have any resource, it will put the queries in queue. That is fine. Now, what is the use? How we can avoid? Like he don't want to wait, or anyone who wants to wait. No one wants to wait because his query will run for 10 minutes, and this query will run because 20 minutes he needs to wait, right? Because once this query got processed, his query should accept. Again, it needs 10 minutes of time, 10 minutes. So total 20 minutes means he needs to sit there for 20 minutes just to get the simple results. Okay, now what is the concept of auto scaling? In auto scaling, as we are specifying the number of servers, let's say same example, Hadoop, I want to load the data from here, like I'm using extra small. I'm configuring only two nodes. Let's configure this, finish, I'll configure. Now let's say for running the query, I'm using the same warehouse, Hadoop warehouse. Now what will happen? Same example, Vamshi submitted query, Mahesh submitted his query, warehouse is really busy. Okay. In that case, Arun will submitted this query. This time, Snowflake will identify this scenario, and what it will do the auto scaling because now I have two nodes, right? So here minimum is one, maximum. Here the compute warehouse doesn't have the auto scaling feature because the minimum and maximum is same. Whereas the one we configured, the minimum node is one and the maximum nodes are two. That means now Snowflake, what it will do is it will detect this scenario. Okay, the third person query is in queue, and this is a multi-cluster warehouse. So what it will do? Then it'll scale up from one cluster to cluster two. That means till now your cluster two is in switched off state. Okay, but when it reaches 100%, and if there is any query in queue which is more than the capacity the cluster one can handle, then it will scale up. It will scale up from cluster one to cluster two. This process is called auto scaling. Scaling up from one cluster to other cluster, this is called auto scaling. So what is the advantage of auto scaling? So here, like Arun, how much time he needs to wait? 10 minutes. Now he don't wait. What will happen? This is busy, that is fine. It will spin up one more cluster, and this cluster Arun query will be moved to this cluster, and his query will start processing. So here he is avoiding that wait time. So if this server is also got busy, then the third server will be switched on. Let's say that is also busy fourth. If the fourth, fifth, sixth, seventh, eighth, ninth, 10th, max is 10 guys. But we are talking about here one server. But if you configure 6x large, we are talking about 512 systems. 512 systems in the backend. That's very powerful cluster. 512 systems means for data science and all they will use, but in real time maybe like you can use till here until here. These are very powerful computing clusters. Petabytes of data smoothly they will process in minutes. Within 6 minutes, TBs of data they'll process. Within 3 minutes, it has the power to process like more than like TBs of data. So anyhow, so everyone good with auto scaling? Okay, so auto scaling is of two types. Scaling up is fine. Scaling up from one cluster to other cluster is fine. Then let's see the scaling down. What is scaling down? Scaling down, let's say maybe Arun got his results in 1 minute. Let's not talk about 10 GB, maybe like only 1 minute he got. So this is still in use. This is still in use. He got his results. Then what Snowflake will do? Snowflake, once it sees like, okay, the work of this cluster 2 is done because it processed Arun got his results. Again, it won't make it to sit idle. It will suspend. Suspend means it will become switched off, shut down in the backend. Then what will happen? They don't charge anything for this. If you use this for 1 minute, 1 paise, 2 minutes, 2 paise. If this is running for 2 minutes, 2 paise. Okay. So the process is called spinning up from cluster 1 to cluster 1. It is called auto scaling, and spinning down from 2 clusters to 1 cluster, it is called scaling down. So that is called auto scaling.